All right, kiddos. Here we are with the chain rule, day 2. I know everybody's excited as I am. Again, a brief idea behind the chain rule. So again, let's go over basic derivatives. Basic derivatives, things with exponents. All right, so it drops down, it multiplies so that 3 multiplies the 5, and then 3 reduces by 1. So basic derivatives. X, okay, so that technically has an exponent of 1, so that comes down and multiplies, and then the exponent of 1 goes to 0, so that's 1. Any regular old constant, okay, technically has an exponent of 0, so that is 0. So that's the basics. The other tricky ones, e to the x is e to the x. Again, I don't know if this has been taught yet, but it's true. I don't know how else to say it. Ln of x is 1 over x. Other basic derivatives. Okay, and then there's all the trig. So sine goes to cosine. Cosine, because it's a co, is going to be a negative. So it's negative sine. Tangent is a secant squared. Leave a little space here. Secant is secant. Tangent. Secant is secant. I feel like I'm missing some important ones, but we'll see. And then there's all the cos. Like, so tangent and cotangent are very closely related, but secant would be a cosecant. Keep messing up on the writing. Let's try that one more time. So I'm sorry, cotangent is a cosecant squared, but because it was a co originally, it's a negative. So cos create negatives. Just like cosecant. Okay, cosecant is going to be cosecant. Cotangent. But again, because it was originally co, it turns out to be a negative. So that's that. Where are we at? We know the product rule. The product rule, u times v, it's going to be uv plus uv. It's the derivative of one and then the derivative of the other. U divided by v, the quotient rule, bottoms up. Okay, bottoms up, so v up, u minus vu. Okay, minus vu, again, it's the derivative of the second, so regular bottom up, and then you flip-flop. Again, the order does matter in the quotient rule. Okay, so regular bottoms up. So as long as you can get that v up, then that kind of lets you know how the rest of the formula is going to go. Bottoms up. All right. Now, last lesson, we talked about the chain rule. And what the chain rule is the layers of an onion. To get at a derivative of something that has layers, you start at the outside and you keep working in and in and in and in and in. All right? So you got to look at embedded functions. Embedded functions. So an example could be 5 plus sine 2x squared. Let's make those different numbers. 3x squared. All to the 4th power. And let's put a number out front. So G. Okay. So again, layers of an onion. So the very outermost is this 2 to the 4th. And so what you do in the chain rule is you start with the derivative of the outermost piece. So that's the 2 and the 4. So that's going to be 8 to the 3rd. 8 to the 3rd. And I leave the inside alone. I leave the inside alone. Okay. Now, the next layer to that onion is the 5 plus sine. 5 plus sine. All right. So what we do is we multiply by the derivative of that. So 5 goes away and sine goes to cosine. Again, we leave the inside of that alone. Leave the inside of that alone. So then inside of that, again, layers of the onion getting peeled away, is 3x squared. And so we multiply by the derivative of that. Okay, and so that is your chain rule. And then from there, you just may need to clean up some stuff, like that is going to multiply that front coefficient sort of thing. But that's about all you would do. But that is the chain rule in a nutshell. So create this layered idea with parentheses, start at the outermost piece and work in and in. Okay, let's see if we can get that accomplished. So we're asked to find the derivative, and obviously there's chain rules. Now, you'll notice in number 13, it's not an obvious chain rule. Like a lot of times you have to rewrite this stuff to make it look more like a chain rule kind of problem. So this is 6x squared plus 1, and then the third root means that it's all to the 1/3. So now it's an obvious chain rule, and the outside is this to the 1/3 portion. That's the outside. So the derivative of this is going to be 1/3, 6x squared plus 1, to the negative 2/3. All right, that's the derivative of the outside times the derivative of the inside. So the 6x squared plus 1. So 6x squared is a 12x, and then the plus 1 goes away because it's a constant. All right. Then the cleanup process, I'm going to put the 1/3 with the 12x. So that's going to be 4x, and then this. All right, so again, I'm going to kind of clean up this thing first. Okay, so it's cleaned up. That's 2, 9 minus x squared to the 1/4. All right, so the outside of this problem is this 2 to the 1/4. Okay, that's the outside, so that derivative goes first. So 1/4 multiplying down, so that'll be 1/2. 9 minus x squared to the negative 3/4. So I minus 1 from 1/4. And then I multiply by the derivative of the inside, and so that would be negative 2x. The 9 goes away, and then the negative x squared is a negative 2x. Okay, here comes the cleanup crew. I'm going to multiply the negative 2x with that front 1/2. So that's going to be negative 1x, or negative x, 9 minus x squared to the negative 3/4. All right, this one is kind of complicated because there's 2 pieces. Okay, there's 2 pieces. So u, for instance, u is x squared. V is x minus 2 to the 4th. So this is going to be the product rule. So what I kind of want to do first before I get into the problem is I'm going to find these derivatives first. So I'm ultimately going to need to know them. Okay, so here's a chain, well, it's kind of a chain rule. So 4x minus 2 to the third, and then I multiply by the derivative of the inside, which is 1. The x goes to 1. So I don't really have to have that. So that would be the derivative of that. All right. So now we can do the product rule. So let's go u prime v. Let's go u prime v. So u prime v plus v prime u. So the first one was u prime v plus v prime u. Okay, again, it doesn't really matter the order, as long as you take the derivative of one and then the other. Not really a whole lot of cleanup in here. What I would probably do is I would turn this into a 4x squared. That's pretty much the cleanup that I would do. Let me minimize this so I can see the next problem and I have room to work. This problem kind of took some space. All right, so next one, again, is the product rule. So x and then the 1 minus x squared. So derivative of the x is 1, so leave the second alone, plus leave the first alone, derivative of the second, and that's 1 goes away, and then that would be negative 2x as the derivative. Here comes the cleanup crew. So this is 1 minus x squared minus 2x squared. So this is ultimately 1 minus 3x squared. Okay, rewrite this thing. So this is x, and then that's x squared plus 1 to the negative 1/2. Okay. Big chain rule on that second piece. So that's gonna be interesting. See if we can handle it here. All right, so u prime v. So I'm going to take the derivative of the x. So x goes to 1, so that just leaves x squared plus 1 to the negative 1/2. So that's the derivative first. So plus, leave that x alone. Now I'm taking the derivative of the second. So this is a chain rule. So this is going to be a multiplication. So this is a negative 1/2. Leave the inside alone. Minus 1 on that. Times the derivative of the inside. So what do we have left? This is x squared plus 1 to the negative 1/2. And this is minus, there's a negative in there. 2 and the 1/2 go away. X and x is an x squared. I think that's what this is. I'd probably leave it just like that. I'm gonna try to avoid it. I'm gonna try it this way. I'm going to try to avoid the quotient rule as much as I can. So this is x plus 5 squared times x squared plus 2 to the negative 2. I'm going to try to avoid the quotient rule as much as I can. I hate the quotient rule. A little insight to Mr. Ashton there. I hate the quotient rule, so I'm going to try to avoid it as much as I can. And so the concept is this: when you have an outside square, it's a square of the insides, but I'm also putting everything on the same level, so it's no longer a division. So thus the negative 2 on that denominator, making it the denominator. Okay, whatever. There it goes. All right, so here we go. So this is a product rule with some chain rule stuff. All right, so the derivative of the first is 2x plus 5 to the first 1 power times 1. Like, that's ultimately what that derivative is of that first piece. And so there's some pieces obviously here that you don't need to have there. So yes, it's multiplied by 1, but that doesn't do anything. And to the first power is implied. Okay, so that's the derivative of the first. Leave the second piece alone. Plus, okay, so that was u prime v right there. So now I'm going to leave the first piece alone and take the derivative of that second piece. Again, this is going to be a chain rule. So times the negative 2 multiplies down, the negative 3, times the derivative of the inside of that, which is 2x. So that's u v prime. Again, there's a chain rule on that v prime. Okay, there's a little bit of cleanup, I'm assuming. So this is a 2x plus 5, x squared plus 2 to the negative 2. Up front, we get a negative 4x. Those are all the coefficients. And then we have an x plus 5 squared, x squared plus 2 to the negative 4. Again, you might see an answer that is like GCF'd a little bit out of this, but I don't know. This is right, I know. It's big and nasty. Okay, so the outside is this sine. Okay, that's the outermost piece. So the derivative is going to be cosine pi x squared. Okay, the inner piece to that is that square. So this is going to be times 2 to the first power, and that's going to be pi x. And then the inside of that is pi x. So that's going to be times pi. So this is going to be bringing all coefficients up front. This is 2 pi squared x, 2 pi squared x, cosine pi x squared. So the first piece is the sine, the second piece is this cosine. They both have a chain rule on there. They both have a chain rule. So the derivative of this is, I'll take the derivative of the blue, so sine goes to cosine, times the, excuse me, answer. Sine does go to cosine, but the inside is a 2x, times the derivative of that in, so that's 2. Leave the second piece alone. All right, plus, leave the first piece alone, times the derivative of the second. So cosine goes to negative sine, so this is a multiplication of negative sine derivative of the inside. So this is going to be 2 cosine squared 2x minus 2 sine squared 2x. I'll leave it like that. It's flirting with the idea of sine squared plus cosine squared, but it won't get there. All right, I'm assuming that there's going to be some trig in here. So this is going to be cosine over sine, that's the cotangent, over sine over 1. All right, so this is ultimately cosine over sine squared. So this is ultimately cosine times sine to the negative 2. Again, I hate the quotient rule. Try to avoid the quotient rule almost at all costs. Right? Almost at all costs. Okay, let that cook there for a little bit. All right, now the derivative. It's the derivative of the first, so that's negative sine. Leave the second piece alone. Plus, so leave the first alone. Leave the first alone. Derivative of the second, so here's a chain rule. So that's a negative 2. Sorry. I'm going to do this thing, but I'm just running out of room. So I'm going to give myself more room here. All right, so I'm just going to start fresh, so it's not all over the place. So I'm stemming off of this cosine sine x to the negative 2. Here we go. So the derivative. So the derivative of cosine is negative sine. Leave the second piece alone. Okay, there's probably some cleanup right there, but we'll ignore that till later. Plus, okay, leave the first piece alone. Derivative of that second piece. Chain rule, sine goes to cosine. All right, so this is this first piece in essence is sine over sine squared. So that's going to be a negative, and then so think of it as this is a sine over a sine squared. Okay, that's what this first piece is. Right? So you can simplify one of those squares. So what this will ultimately be is a sine of -1. Okay, that's a sine on the denominator. Okay, aka a cosecant. That's a cosecant. Minus 2 cosine squared sine to the -3. Right? So, sure, there's probably something fancy in there. It's a cotangent squared. So writing this alternatively, this could be a negative cosecant minus 2, and this is a cosine squared over a sine squared, so that could be what, a cotangent squared, or a cotangent squared, and then a sine squared on bottom cosecant. So like, alternatively, that could be your statement. Again, whatever floats your boat. Bottom line is all right. It's a nasty problem. It's an ugly problem. All right, find the and evaluate the derivative. Use the graphing utility to verify your result. So find the derivative at that. Yeah, find the derivative. All right, so what this is originally is x squared plus 8x to the 1/2. So the derivative of this, I'm going to call it f prime. The derivative is going to be 1/2 to the -1/2 times the derivative of the inside, which is 2x plus 8. You can put this together, kind of. I'm going to leave it just as is, because a lot of times, like, things get messed up when you clean it up. So, what is the derivative? And they want to know what is the derivative at that point, so that makes the x1 of that point. One plus 8 -1/2 times 2 plus 8. So this is 1 over 2. And this is a square root of 9 times 10. So this is what 10/6 is 5/3. Using graphing utility to verify your results. So this answer would, in a calculator version, is going to be 1.666667. So let's see if we're right. So they want us to use a graphing utility or a calculator, whatever, to verify your result. I'm going to just use the calculator, not really graph it, but I'm going to use this n deriv of the square root of x squared plus 8x with respect to x, so comma x, at the x coordinate of 1. Gosh darn, we're good. That's good stuff. Yeah, that was it. All right, next, find the equation of the tangent line. So again, the derivative is the slope of the tangent. So what is this originally? So the derivative no, I'll write it how I like it first. 2x. And I like this stuff, the negative exponents and stuff like that. Mathematically, that's easier to get. What this may look like to the untrained eye is 2x squared minus 7. That's all to the negative 1/2. So there it is. All right, so I like the red version. I like that version. That's what I like. But mathematically, it might be easy to get this this green answer. Okay. So what is this at? So that's all slopes. Now we specifically want to know what is the slope when x is equal to 4. So that's going to be, I'll look at the green, so that's 2 times 4 over 2 times 4 squared minus 7. So this is 8 over 16, 32, 25, 5. A lot of mental math there. So 4 squared is 16. 16 times 2 is 32. 32 minus 7 is 5, or 25, excuse me. Square root of 25 is 5. So this is ultimately the slope of the line. That's ultimately the slope of the line. Okay, we're not quite done with the problem, so relax, we're not there yet. Okay. So now here comes the coup de grace. This is, we want to know what is the equation of the line. So y minus y1 is equal to m x minus x1. Now I have to add 5, so that would be adding 25 fifths. That's what, maybe 7 fifths. Okay, I'm not going to worry about graphing it, but I am going to use my graphing utility to verify my result. So what is my result going to look like actually before I know if I'm right or wrong? So 8 fifths. So this is going to look like what? 1.6 x, and then 7 fifths is what? 1.4. Right, 7 fifths. Okay. So we graph our original. So the square root of 2x squared minus 7. Okay. So we graph that. And we want to know the derivative. So we go second, draw the tangent line at when x is equal to 4. That's 1.6, blah, 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 0, 0, 0, minus, plus negative, 1.4. Wow, we're good. That's awesome. So our equation of our tangent line at 4 fifths is correct. So notice that 4 is 4/5 or 5. Find the second derivative of the function. Easy peasy. So I noticed that the original is x minus 6 to the negative 1. So the derivative is negative 1, x minus 6 to the negative 2. Derivative of the inside is 1, so that's negligible. And then the second derivative, again, derivative of the outside is a positive 2. The negative 3, derivative of the in is 1. So there you go. Okay. If blah, 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 then h prime. All right, so I got to notice that h is equal to what? Cosine 8 theta to the third. So that was cosine to the third power, or cosine third 8 pi, which is the same thing as to the fifth power. Okay, it's kind of better to look at it like this. Okay, so the prime is going to be third power 2 times derivative of the inside is going to be negative sine times so cleaning this up for myself, this is going to be negative 24. This is negative 24 cosine squared sine. Something to that effect. Negative 24, well, that doesn't really help us. Cosine squared, okay, getting closer to sine, there it is. Boom. Drop the mic.